This video is going to have a look at how do we write and use recursion relations for arithmetic sequences. Now, the form of a recurrence relation for arithmetic sequence is T1 is equal to A, Tn plus 1 is equal to Tn plus D. So breaking that up, our T1 is our first term in the sequence. So that's the number we are starting at, and A is going to be its value. Tn plus 1 is the next term in the sequence. So Tn plus 1, the next term, is equal to Tn, which is the current term in the sequence, and it is going to be plus D, which is the common difference. So the common difference is the amount we are increasing or decreasing by each time we move on to the next number in the sequence. If we are decreasing and not increasing, instead of being plus D, it's going to be a minus D. So depending on whether we're increasing or decreasing, whether it will be plus or minus. So a recurrence relation tells us that the first term is equal to this value, and then the next term is equal to the current term plus the common difference. So that is how we write our recurrence relation using T1 is equal to A, Tn plus 1 is equal to Tn plus D. So let's have a look at a couple of examples of how do we use and apply these recurrence relations. So in the first example, we have a recurrence relation. T1 is equal to 4. Tn plus 1 is equal to Tn plus 6. So if I wanted to write a sequence based on this recurrence relation, there's two important pieces of information that I need to extract from the relation. The first one is 4, and that is going to be the first term in the sequence. So that's the number I'm going to start at. And plus 6 is going to be the common difference. So that is what I'm going to be going up by each time. So if I wanted to write a sequence based on that recursion relation, I would start at 4, and then I'd go 4 plus 6, which is equal to 10, and then it'd be 10 plus 6, which is equal to 16, 16 plus 6, which is equal to 22, and then 22 plus 6, which is equal to 28. So each time in the sequence, I'm increasing or adding a number, I'm adding on a value of 6. So that's an example of how I can use a recurrence relation to write an arithmetic sequence. So let's have a look at a second example where I have a sequence and I want to write the recursion relation from it. So I have a sequence of 36, 31, 26, 21, and 16, and I want to write the recursion relation for it. So to be able to write the recursion relation, I need to first identify two important pieces of information, and that is going to be my first term and my difference. So my first term is going to be 36 because that's the number I'm starting at. And then when I'm looking at the sequence, I can see when I go from 36 to 31, I'm subtracting 5. When I go from 31 to 26, I'm subtracting 5, and I'm subtracting 5 every time I move on to the next number. So then that tells me my common difference is going to be negative 5. So now that I've found my first term and my common difference, I can write my recursion relation. I'm going to start off by declaring the first number. So T1 is equal to 36, and then I'm going to go Tn plus 1. So the next term in the sequence is equal to Tn, or the common term, minus 5. So my recurrence relation is T1 equals 36, Tn plus 1 is equal to Tn minus 5. So the next term in the sequence is equal to the current term minus 5. So there were a couple of examples of how we can use the recursion relations with arithmetic sequences.